Hey everybody, we're getting ready to do our wind chill lab, so if you're not here today, I'm going to show how that's done. This is a lab about why sometimes the temperature says one thing, but the temperature feels something different. The first part is wind chill, and it says the wind chill temperature is how cold people and animals feel when outside. Wind chill is based on the rate of heat loss from exposed skin by wind and cold. So it's cold out and it's windy, and the wind makes the temperature feel colder. So when the temperature says it's 40 degrees, it feels like 20 degrees. So it says as wind increases, it draws heat from the body, driving down the skin temperature and eventually the internal body temperature. So you will want to, the National Weather Service wind chill calculator. It's right here, and I will in a second. You're going to fill out this data table. If it's 22 degrees outside with a wind chill of 5 miles an hour, so 22 and 5, if I go to the wind chill calculator, I think that was Fahrenheit. So, and 5 miles an hour, and I convert. And it tells me Fahrenheit and Celsius. You just write those into the box. Pretty simple stuff. Psychrometer reading. This part you're going to need some equipment, so I'm going to do that with you right now. A psychrometer is an instrument that measures temperature with a dry thermometer and temperature with a wet thermometer. It sometimes feels hotter because it's so humid. Sometimes it feels colder because you're wet. The wet bulb will have water that's evaporating. Evaporation is a cooling process, so it will read less. Find the relative humidity of your thermometer using a psychrometer, which we're kind of going to make. Obtain 2 thermometers. Yes, right here we have 2 thermometers. You might notice these thermometers have Celsius on one side and Fahrenheit on the other. Wrap one bulb with paper towel, wet paper towel. So I'm going to tear a little piece of paper towel, take it over here to the sink, get it wet. Wring it out a little bit so it's not dripping. I got paper towel to wrap around. If I can get you to see this. I'm trying to do this without a support. The bulb of my thermometer. So the bulb, oops, it's coming off, is wet. Now, I have 2 thermometers. Hang on. 2 thermometers. The first one I'm gonna read when I'm just holding it. Here's the dry one. And it says right at 72. And then the wet one says about the same, maybe 73. They might have been different to begin with. So you'd write that into your box. And then the second one's a little light waving. Okay, you want to keep the dry thermometer dry. Oh, crap, sorry. Dry thermometer dry. And you also don't want to shake the alcohol in the thermometer to the bottom. So I'm just going to give it wind. Right? So I'm giving it wind. Trying to make it colder by making it windy where it is. All right, so my dry one, oops, looks like it's 71, or excuse me, my wet one is 71, and my dry one is now 74. So I don't know if the temperature changed in this room or what. So I'm going to do it again, seriously windy. But again, you want to make sure you're not shaking the alcohol down in it. So I'm going to really give it some wind. Really give it some wind. Okay. Let's see. Sorry, I'm trying to give this thing some wind. Okay, so it looks like we are still at about 75 and about 72. So it must not be, it must be pretty moist in here. It's not making a big difference at this point. So you should have the wet bulb, dry bulb, and you can do the difference with math. And then you're going to use this table. So let's say the difference, I think the difference on one was 3 degrees. So the difference would be 3 degrees. So you're going to go, dry bulb temperature was what, 72? You're going to go to 72. 3 degrees difference. So you'll go over here and it feels like 86. So you'll just use the data table to fill in the rest of it. So I believe these were all, let's see, the dry bulbs were all 72. The wet bulb was 72. It's still wet. 72, 74, and 76. So, but the dry bulbs should all been the same. So what's the difference and what's it feel like using this data table right here? The last part is the heat index. It feels much hotter if the humidity amount of water in the air is high. If the amount of water in the air is high, water on your skin will not evaporate well. Evaporation is a cooling process. That is why you feel cold when getting out of the pool on a hot day. The pool water is evaporating from your skin. Use the chart below to determine the relative humidity and determine the danger level. All right, so here's the chart. The first one says the temperature is 96 and it's 55 degrees humidity. So it's asking you what the relative humidity is and then what's the danger level. So 96 and 55. It's 96 with a 55 degree, that's 112. And 112, where'd it go? 112 is in the orange, so it'd be in danger. So you should be able to do the other ones on your own. Have fun.